Hi everybody, Ms. Mocano here. In the last video, we went over some power calculations that were right out of this assignment, power and electrical energy. So we went through the first part of this assignment that was all about power, calculating power in watts and kilowatts and so on. For this part of the video, we're going to go through the electrical energy part of the assignment. So let's move over to the Jamboard and a little bit of background on electrical energy. So electrical energy is simply defined by the formula of power times time as given to you here. So all the appliances we have in our homes, all kinds of appliances like that, like a light bulb, like a stove, like a hair dryer, anything like that, that has a power associated with it, okay? So a number of watts or kilowatts associated with it. When you run it for a certain time, for example, your stove at home, when you run that for a certain amount of time, it uses a certain amount of electrical energy, which is something that you pay for, right? You all know that your parents, maybe yourselves, are paying for electrical energy. So that is what this equation tells us, okay? It gives us, based on the power rating of a certain appliance or object, and based on the amount of time that you use that object, how much energy is it using? And then knowing how much energy you're using, the electrical company charges you for that energy. So once we know how much energy we're using in kilowatt hours, and we know how much we're being charged for every kilowatt hour, we can actually calculate how much are we being charged overall to run our appliances. So we're going to see some applications of this in this assignment. But before we get into that, I wanted to point out the units. So units, as we talked in the previous video on power, units are really, really important. If you do not have the correct units, your calculations will not work out. So electrical energy is abbreviated as capital E, as you can see in this formula down here. Power, as we know, is abbreviated as capital P, and time is abbreviated as lowercase t. Now for units, power, we already discussed this, is in watts. However, when you use the electrical energy formula, you have to convert that from watts to kilowatts. And how do you make that conversion? Well, you go back to our unit 1, back to our trusty little mnemonic here, King Henry died by drinking chocolate milk, kilo, hecta, deca, base, deci, centi, and milli. So if you're trying to convert from kilowatts to watts, well, watts is your base unit, kilowatts would fall under kilo, and you use what we learned in unit 1. If you need to go back and review that, please do so, to convert from one to another, okay? So going back to this equation, your power has to be in kilowatts. Time is in hours, and your electrical energy that you're going to calculate is going to be in the unit of kilowatt hour, which has this abbreviation right here. So kilowatts, K for kilo, W for watts, and H for hour. So let's see how this works out. Let's apply this in an example. So let's take this example. A 100-watt light bulb is turned on for 5 hours every day. Calculate the total electrical energy used each day and its cost. All right, so we always start off by reading the problem really carefully and seeing what the problem is giving us. We have a handy little list that I made here for you guys. In the future, you should make your own little list of all the variables, all the different things in the problem that could possibly change. And we're going to plug in the things that we know and the things that we asked to find. So the problem is telling me about a 100-watt light bulb. What is that? Well, 100 watts, the unit of watts kind of gives it away that this is a power rating, okay? So the power is given to me as 100 watts. However, I know that if I want to use this formula, I need to convert that watts into kilowatts. So I'm going to take 100 watts. And if I want to convert that into kilowatts, I know that I can use my little scale over here. So I'm going from my base unit of watts to kilowatts. I got to jump 1, 2, 3 steps to the left. So I'm going to go and do that. So if I take my decimal point and I jump 3 spots to the left, 1, 2, 3, well, 100 watts is going to turn out to be 0.1 kilowatts. All right, so now I can put that in here. That is something that I know. For this light bulb, it's 0.1 kilowatts. It's turned on for 5 hours every day. What is this 5 hours? That's just telling me the time. So I could put that under my time. I got 5 hours. Problem is asking, calculate the total electrical energy. So electrical energy, I got my formula right here. Electrical energy is power times time. So I have the power, 0.1 kilowatts, times my time, 5 hours. They are both in the right units, so I can use my formula with no problem. And 0.1 times 5 is just going to be 0.5. And my unit is going to be kilowatt hour. So kilowatt hour is my unit. All right, am I done with this problem? No, I'm not done, because I found my total electrical energy that this light bulb uses when it's on for 5 hours. But now I got to find out how much do I have to pay for that energy. So 0.5 kilowatt hour is my energy, and the electrical company is charging me for every kilowatt hour that I use. They're charging me this much money, 0.0839. So how do I find out my total cost that I have to pay for this light bulb for 5 hours? Well, I'm just going to take my energy that it's using, so 0.5 kilowatt hour, and I'm going to multiply that by the cost that the electrical company is charging me for energy. And if you do that multiplication, your final cost will be approximately $0.042, which is going to be approximately 4 cents. Okay, so that's how much money you are paying when you have a light bulb that's 100 watts, that's on for 5 hours, and that the electrical company is charging you this much for it. That's your total cost for that 5 hours. Let's do another problem. Problem number 14. In this problem, we have a coffee maker that's 1,200 watts. What is that watts giving me? That's giving me the power. So the power of my coffee maker is 1,200 watts, which I know if I want to do anything with electrical energy and use this formula, I'd better convert it to kilowatts. So 1,200 watts, I'm going to convert it to kilowatts. 1, 2, 3. I got to move my decimal point 3 to the left. So that's going to give me 1.2 kilowatts. So that's my power, 1.2 kilowatts. All right, now I'm using this coffee maker for 3 minutes. So can I just put 3 minutes here? No, because look at my unit. My unit, if I want to use my formula, my time has to be in hours. So I got to somehow convert that time of 3 minutes into hours. How do I do that? I'm just going to multiply how many minutes are in an hour. Well, I know that 1 hour has 60 minutes in it. So if I take 3 minutes multiplied by 1 hour over 60 minutes, that's the same as 3 minutes divided by 60 minutes. So that is going to give me 0.05 hours. Okay, so 3 minutes is equivalent, is the same thing as 0.05 hours. So now I'm in good shape to use my time right here and to say, okay, my time is 0.05 hours. Energy in kilowatt hour. Now I can use my equation. Energy equals power times time. Power times time. I have 1.2 kilowatts for power. I got 0.05 hours for my time. I do that multiplication and I am going to get, and let me just continue down here because I'm running out of space a little bit. I'm going to get 1.2 times 0.05. That is 0.06 kilowatt hour. So that is the energy that my coffee maker when I have it on for 3 minutes, that's how much energy I'm using during that 3 minutes. Again, I'm not done, okay? I calculated the electrical energy, but I have not yet calculated the cost. So how much money am I going to have to pay? Well, I'm going to take the energy that I'm using, 0.06 kilowatt hour, times how much the company is charging me for every kilowatt hour that I use. So the company is charging me 0.0839, about 8 cents for every kilowatt hour that I use. So that's dollars per kilowatt hour that they're charging me. And when I do that multiplication, my final answer is going to be $0.005, which is approximately equal to 0.5 cents. So when I use my coffee maker for 3 minutes, I am paying about half a cent for that 3 minutes of use. Okay? So that's how this works. Now, in further problems down in this assignment, particularly, let's see, problem number 15, it's asking you to calculate the cost for a day, for a week, for a month, and for a year. You basically would follow the exact same line of thinking that we did over here. So if you understand what we just did over here, you should be in good shape to go ahead and calculate the power and the energy consumption, for this water heater for a day. Then you can calculate the cost that you have to pay in order to use your water heater for a day. Then if you know the cost for a day, clearly you can, how much it costs you for a day, you can take that, multiply by 7 days a week to figure out how much you're paying for a week, and so on for a month and year. All right. I hope this video was useful to you guys, and I will see you in class.